When the tide is right and the winds stir up a handy sou'east swell, tourists and locals alike gather to witness an awesome event. This is the Kiama Blowhole on Australia's east coast.
What makes it so spectacular is the power. It's awesome. You can feel it under your feet. A huge vibration as the waves hit a big cave under all this rock. The air in the cave is compressed as the wave travels through it, and the only way that air can escape is through this hole in the roof. Mother Nature has been demonstrating her power here for hundreds of years, and her message is finally getting through. This is pure, green, limitless energy, and it's free for the taking.
It's an accepted fact that the oceans carry enough potential energy to power every single country on Earth, more than 5,000 times over. But finding an efficient way of harnessing that power has proven very difficult.
The problem facing anyone trying to design a wave generator is obvious. Waves aren't the least bit consistent. Their size totally depends on wind and tide. And as we all know, that changes from day to day. But at least one scientist has heard Mother Nature's message. Basing his design on the Kiama Blowhole, he's begun an energy revolution.
Dr. Tom Dennis is Executive Director of Energetic Australia, and the man who dreamed all this up, a 500-tonne floating wave energy generator that he claims is 10 times more efficient than the best ever built.
See that coming down the line.
This fully operational prototype is moored in Port Kembla, south of Sydney, and is about to be towed into place on the rugged ocean side of the harbour's breakwater.
The device you see out here now is capable, even at this early stage of the technology, of producing enough power for 500 homes.
Working at maximum power, this plant could produce double that amount. That's 1,000 tonnes of greenhouse gas a year that's not going into the atmosphere. There's no disputing that wave power has enormous potential. Back in 1985, Beyond 2000 reporter Ian Finlay toured a Norwegian wave energy experiment that harnessed the rise and fall of passing swells in a huge vertical column. It worked on the basic principle that still applies today. The water level inside this ribbed chamber rises and falls like a giant liquid piston with each passing wave. The compressed air from a rising wave spins a turbine at the top, and as the water drops, the air is sucked back through, again spinning the turbine. The breakthrough with Dr. Dennis's design is that, unlike the Norwegian model, it can harness the power of waves even when it's relatively calm.
Well, you can see the turbine operating at the moment just quite slowly because we don't want to put ourselves in any danger, but in real operational mode, the blades will be spinning at approximately up to 700 RPM, and the airflow down this passageway here can be as much as 500 kilometres per hour. What we've done is come up with a radically different turbine, and they sense the flow and they react within milliseconds to move to whatever is the best position to extract the most amount of power.
And there's another feature that makes this wave generator so much more effective. These huge parabolic walls either side of the water chamber. They're shaped just like the cave entrance to the Kiama Blowhole.
Seems incredible that no one has thought of this before. It's such a basic solution. Like a satellite dish that concentrates radio waves into a powerful signal, these walls concentrate ocean waves into a powerful force, tripling the energy of a 2-metre swell to that of a 6-metre swell.
So even in swells under a metre, power production is still commercially viable. And that's a first in wave energy generation. For the next 12 months, the rig will sit on the ocean floor 200 metres off the Port Kembla coast, being lashed by wind and wave to test its structural stamina and prove equipment reliability. A cable running to shore will add about 1 gigawatt hour of electricity per year to the local grid. Then, if all goes to plan, they'll have critical data proving to the world that their wave power is cheaper than wind power, solar power, and even fossil-fuelled power.